In the next set of videos, we're going to use this bunch of formulas 1, 2 and 3. So here we have the root in the numerator and we have seen formulas which are in the denominator, the roots. Right? Similarly, we have root in the numerator. So it's a combination of whatever we saw in the denominator, that expression, along with that some more expressions. Right? Again, if you are thorough with this, then this will make sense. So everything is built on another. So my advice is take your time, learn the formulas by deriving it, try to derive in your head, then it will make sense. So yeah, let's prove this. So there are 1, 2 and 3. I'm not going to write them, so I just showed it to you guys. So let's start off with the proof. So we have to integrate 1 into square root of x square minus a square into dx. So we're going to make use of integration by parts. Here I'm going to take u as square root of x square minus a square. Right, that makes sense. If I knew the integration of that, then no point in doing the whole thing, is it not? So v has to be 1. Now if I differentiate u, I'll just do it off here itself. So that would be 1 by 2 root of x square minus a square, and again as per the chain rule I'll need to have 2 into x. Right, this is as per chain rule. Okay, so I'll put this in the next slide. Anyways, we have to make use of this again, right? So it makes it convenient. And v dx is nothing but x. 1 dx, which is nothing but x. Okay. So what is the next thing? Yeah, listing the formulas. So we have I is equal to, or uv dx is equal to u integration of v dx minus integration of u prime integration of v dx, closing the brackets, and we have dx. Right, and next thing is u is 1. So integration of this is, sorry, not u is not 1, u is square root of x square minus a square. Then the integration of v is x, so I'm just rearranging them, minus integration of x square by u prime is not x square, sorry, my bad, integration of v dx is x, while u prime is 2 into 2x into x by 2. Oh, I can cancel 2 and 2 over here. Okay, let me restart this again. Now I'll open the brackets. U prime is x by root of x square minus a square, and integration of this is x, closing the brackets, dx. Now we have x square root of x square minus a square minus, I'll call this as I, 2. So it's, it's safe to take it apart, take it aside and do it. Make sense? Okay. So we have I2, which is to do with integration of x square divided by square root of x square minus a square into dx. So if you guys remember that cycle scenario, that is, we get back I, that's going to happen over here. If you think about it, it's very simple. So what should I do to get that? Go to a situation wherein we get I over here. Okay, let me tell that to you guys now. So x square I'm going to subtract with a square, and then I'm going to add with a square, d of x, entire expression divided with square root of x square minus a square, and bit of rearranging, and we have x square minus a square d of x divided by square root of x square minus a square plus a square integration of root of x square minus a square, and this clearly is square root of x square minus a square into dx. I hope this is not confusing. So this is nothing but a divided by, I'll write it over here, or let me write it over here itself, only for your understanding. So this is something like a divided by square root of a, which is root of a itself. Agree? Okay. Yes. Moving on. So we have a square, and integration of this is a standard formula. As I mentioned before, we need to know this set of formulas to help us out. So what is it? Log of modulus of x plus square root of x square minus a square, right? So we have log of modulus of x plus square root of x square minus a square and a constant. I'll take it as k, but this particular expression is nothing but I, is it not? Therefore I2 is equal to I plus this entire expression, which I don't want to write again. Let me just copy this. Okay, and moving on, I will be equal to x square root of x square minus a square minus of I, right? It's over here itself. I'm just substituting into that, plus this particular expression again, plus some constant and bit of rearranging, and we have, if I multiply with minus 1, this will become minus I. If I transpose, it will become I plus I. So this is 2I. Simple maths. Please don't take too many steps to get to this point. And we have minus of this particular expression plus a constant c, and finally I is equal to 1 by, or x by 2 root of x square minus a square minus of this particular expression again divided by 2 plus a constant, right? I think I have the right answer. Okay, so this formula is something even I find it difficult to remember, but yeah, I think systematically and I get to that point. So I know that it's a cyclic Walla scenario. So the integration happens, the formula happens to be derived in a manner wherein I get I and I. So I know that 1 by 2 will come in both the places. And I know we are doing u into v, that basically this, and I know that, I remember that v is 1. So when you integrate and all, you get x. So x into u minus, and I remember a square by 2, and this part is something that I remember from the previous formula. So again, I remember it by deriving in my head at some level. Of course, if I sit and practice it a bit more, then things will be very concrete. So this is how you guys have to learn. Okay, so don't by heart the formulas throughout. It's of no use, because end of it you will be confused. Okay guys, learn to derive it and then remember.